Hello, and we're going to talk today about dilutions. So we've already talked a little bit about how this is more dilute than this as a solution. But we're going to look today at how we make calculations based on dilutions. So if you've ever made, say, taken concentrated orange juice and made a pitcher of juice out of it. First you put the concentrate or the concentrated juice, orange juice, in your container, you add a bunch of water, and voila, you get your diluted orange juice. Here, we have a certain amount of orange juice in our pitcher. We still have that exact same amount of orange juice, it's just diluted. We didn't take any away, we didn't add any, we just added water. So the amount of orange juice before is the same as the amount of orange juice, the concentrate part, the orange juice, after adding the water. And our volume obviously increased. It's the same in chemistry. If we look at moles, the moles of solute after the dilution is going to be the same as the moles of solute before dilution. We didn't change the numbers of moles of solute before and after diluting our solution. We simply changed the volume, we increased it, and we changed the molarity. We decreased the molarity because the molarity would be the moles of solute, which remains the same, per liters of solution. And when we increase the volume, the liters of solution, the molarity then decreases. So how do we know how much solute we have in a dilute solution? So we have a solution of something. Remember how we calculate molarity. Molarity equals moles of solute divided by liters of solution. We can rearrange this equation any way we want. We can say moles of solute right here equals the molarity, and if we simply multiply both sides by liters of solution, then we can cancel these out, and we get moles of solute is going to equal molarity times liters of solution, volume in liters. So if we rewrite it this way, we can do this little example problem here. Let's say we're given in our example problem 17.5 molar stock solution of acetic acid. Right here, there's the molecular equation. We're told we should prepare a 500 milliliter solution of 1.00 molar acetic acid. So how are we going to do that? First, we need to find out how many moles of acetic acid are going to be in that final solution. So that is our first step. How are we going to find out how many moles of acetic acid are in the final solution? Well, let's look up here at the final solution. We have 500 milliliters, and we have 1 molar acetic acid. Wow, that is surprisingly volume times molarity. Like we said here, we have molarity of the solution and the volume of the solution. If you just remember molarity equals moles per liter, you also know the volume and the molarity right there. So we'll be able to find our moles of solution by taking the molarity, which is 1.00 molar, times the volume. Now, I need you to notice something. Our volume is not in the right units. We want our volume to be in liters. This volume is in milliliters, so we can convert that. 500 milliliters is the same as 0.500 liters, right? And our answer here then will be 0.500 moles of acetic acid. Okay, so that was our first step. Let's go ahead and write that back down again. 0.500 moles of solute, acetic acid, that we have. Remember, that's going to be the same, okay? So what do we do next? We need to find the volume of the stock solution that contains this 0.500 moles of acetic acid. Let's go back to our definition of molarity. Molarity is moles of solute over liters of solution. And I want to emphasize, memorize this formula. but you don't need to memorize all the different permutations of it. We can rearrange this formula here if we multiply both sides by the liters of solution, right? We get rid of liters of solution here. And then if we divide both sides by the molarity, and divide this side by the molarity, these end up canceling out, right? And I know this is really hard to read, but we get moles of solute divided by the molarity is equal to our volume. And I just rewrote that here. So I sort of made a mess of it there. But we can simply rearrange the equation, or you could just plug in the values where you want to plug them in and do a little bit of algebra to work that out. But you really only need to memorize this. You don't need to memorize every permutation of it, because you should be able to calculate that just from basic algebra. So let's look at finding the volume of our solution. And we're going to do that by saying our moles of solute, which we already know, 500 moles of the solute, divided by the molarity of the solution, which is 17.5 molar, or moles per liter. Now, when you have the liters right here, will end up being, it is the denominator in the denominator, so it will end up being on top of the fraction. And our answer is going to be, let me see where to write this, 0.0286 86 liters, or you could rewrite it as 28.6 milliliters of solution. So we're not done yet, because our problem said to prepare this. So we did the calculations, right? And we found that we need either 0.0286 or 28 liters, or 28.6 milliliters is how much we're going to use, right? Of solution. So how are we going to prepare it? Here's how we prepare it. We're going to measure the 28.6 milliliters of the 17.5 molar acetic acid. Then we're going to dilute to our final volume of 500 milliliters. And that's what we use this little graduated flask for. It has a mark on it right here that indicates exactly 500 milliliters. So we measure out in a graduated cylinder our 28.6 milliliters of the 17.5 molar acetic acid, pour it into the container, and then we fill it up to the line with water. And that's how we actually would prepare it in the lab. Now, that seemed kind of complicated. I'm going to give you a really easy way to always think about this. We know, here's our nice little fancy equation. We know the moles of solute remain the same before and after the dilution, right? So the moles of solute, you'll remember before when we rearranged our equation for molarity, we get the moles of solute equals the molarity times the volume, okay? And don't worry about the little subscripts yet. Molarity times the volume before is going to equal the moles of solute. And that's going to equal the moles of solute after also. The molarity times the volume after the dilution is equal to the moles of solute. It's going to be the same, right? Before and after. So here's before dilution right here, and here's after dilution. The ones here just signify before dilution, initial. The twos, the final volume, or the volume after the dilution. So MV before equals MV afterwards. Molarity times volume initial equals molarity times volume final after the dilution. So you try doing this with this equation. It makes it pretty simple. What volume of a 16 molar sulfuric acid must be used to prepare this? 1.5 liters of a 0.10 molar sulfuric acid solution. So pause the video, you give it a try, and we'll solve it together on the next page. Okay, so I'm sure you guys did great. You probably got the right answer. Here's the answer you can check if you can follow along if you need to. So here's our problem again. Here's our really handy little equation that we can use. Remember, we just derived this from the definition of molarity, moles per liter, right? And rearranging that. I always like to write down what I know first. So initial, what is our initial solution? Well, we have the molarity of the 16 molar sulfuric acid initially, right? That's our initial 16 moles per liter, 16 molar. And we don't know the volume. We want to know what volume we want to use of that. I'm not sure how much I'm going to take of this yet. Our final numbers are going to look like 0.10 molar, right? This is the molarity that we want to prepare. So our final solution is going to be 0.10 molar sulfuric acid. And the volume is specified to be 1.5 liters. So let's just set this up. We can simply say 16 times V, unknown. We don't know what our initial volume will be yet, equals the 0.1 right there times 1.5 liters. So when we do this math, we get the volume to be 0.0094 liters. That's the same as 9.4 milliliters. And you know now that you'd take that 9.4 milliliters of our 16 molar sulfuric acid, right? Then you would pour that into your graduated cylinder, and you would fill the volume up to 1.5 liters total. And that's how you'd actually prepare that. So you guys will have to practice some of these problems, and good luck to you. And on the next page, we've got a couple ideas for advanced proficiency. Here is an idea. You want to pause the video and probably just read through this. Just an idea of how you might be able to practice doing some of these things in the lab. And you don't have to do this. This is just for advanced. But you can prepare a standard solution. Here's a few different possibilities you could use to prepare these. And they're all nice, pretty colors as well, purples and blues. Use then that standard solution to obtain more dilute solutions. List the items you need, the safety precautions, write out your procedures, show all your calculations, and get your procedures approved. And you can go in the lab and try this, make a pretty little rainbow of some different concentrations of these solutions. So look forward to seeing you in class.